Okay, so a friend of mine asked me if I can create him a custom pitch and roll indicator for his 1978 Jeep Wrangler. And so, here it is. You can see that as I tilted this board, the images are changing accordingly. And so today I will show you how to make this project, and it will be actually very simple, so let's get started. Let's go all the way to the beginning, because when my friend asked me, my immediate response was that he doesn't need my help. I told him that he can just go to AliExpress and there will be some pitch and roll indicator for just a few dollars. And guess what? I was completely right. Here is one product that is called HUD, and although it's not a head-up display, it's still a pitch and roll indicator. And it even has some alarm when you are tilting your car too much. If you power it up using the USB-C cable, you get the pitch and roll indicator as well as the speed indicator using the built-in GPS sensor. But if you connect it to your car using the OBD port using the provided cable, you get a fully featured dashboard showing all kinds of information, including the RPM, the fuel level, and pretty much anything that you might expect from the dashboard. But my friend wasn't happy, and it wasn't because of the lacking OBD2 connector on his Jeep Wrangler. It was simply because he wanted to see his own car image, or at least the outline of his car, and not some generic one. That said, I like this unit quite a lot, so I reached out to the company making those. It's called Carpuride, and they were kind enough to sponsor today's video. So if you are thinking about updating your car or motorcycle with a new display, you can use the link down in the description and get $50 off. So thank you Carpuride, and let's get back to our project. So I've decided to make this project with only one requirement, and that is to make it as simple as possible, just so anyone could follow. And when I think about simple projects, I usually think about using the Arduino Uno board, but for the simplest possible projects, I think about a different board, and that's this one called microbit. In order to get started, you don't have to download anything, you just go to makecut.microbit.org and create a new project. Give it some meaningful name, for example pitch and roll indicator, and hit the create button. In here you create the application by dragging those individual blocks. So let's start with something very simple, and it is maybe showing something on this 5x5 LED matrix display. I will open this basic group and select this show icon block and drag it inside the on start block. And just as I do this, the emulator on the left side will update and show us this icon, and of course I can select a different one if I want to. Let's for example go with this one because it looks like a car, right? I mean, with a little bit of imagination. Now there are two ways how to run this application on the real microbit board. In both cases you have to connect the microbit to your PC using the micro USB cable. And once the microbit is connected, it should immediately appear as a new external drive. So inside the browser, you can click this download button to download a hex file and copy it into this folder. But probably a better way is to just directly connect the browser to the microbit by clicking those three dots. Select connect the device. Here it tells you to connect the microbit to your PC, click the next button. And here it tells you that you should select the microbit in the pop-up window, so click the pair button. Here is a pop-up window, so I will select my microbit and click the connect button. And once the microbit is successfully connected, I can just click the download button and it will download the hex file directly into the microbit without the need to copy the files around. And so just like this, I can easily show an image on this tiny little display. Now one thing that I like about microbit is that it has a lot of stuff included. We've just used the display, but you can see there are also those two buttons. This logo is actually a touch logo, the touch button. There are some pins on the bottom of the board. And when you flip the board around, it tells you there are a lot of sensors, including the microphone, accelerometer, compass, and so on and so on. And that's great because we want to create a custom pitch and roll indicator. And for that we need to know how much this board is actually tilted. And we can get this value using this built-in accelerometer. And I can easily read those values using the dedicated blocks. So back in the MakeCode editor, I can jump into the input and click the more input. And here I have the rotation block, so if I drag it inside, I can choose to get the value from pitch or from roll. Now this alone will give me some number, and I want to show the number, and I can show it on the same LED display by going to basics and selecting show number blocks. So I want to show the number, which will be the roll number, and I will put everything inside the forever block and maybe give it a little bit of delay, so I'll drag in the pause 100 milliseconds in here as well. And once the simulator restarts, you can see value 0 being displayed. I can simulate the tilting of the board simply by moving the mouse over the board, and that will pitch and roll it. So simply by moving the mouse I can create the different pitch and roll angles, and you can see that the number updates. So if I try to move my cursor around the middle of the board, I get value 0. If I move it to the left side, I can see the value of minus 92 or whatever. And if I move it to the right side, now it should be a positive value. So now it's showing 93 being the positive number. Again, if I keep the cursor around the middle of the board, I can easily see switching the numbers 1, 4, and so on. But once I reach the numbers above 10, it starts scrolling and it's not so easy to read those numbers. And it will be definitely not possible to read those numbers while you are driving in the car. Thankfully, there are other ways how to display those numbers. And one of the way might be going into the LED section, and here is a block called plot bar graph. So if I put this one in here, and again use our rotation block, let's go with pitch this time, which will be up to 90. It will just start filling up the graph as I move my mouse around the board. Although it looks like that it's treating those negative values in the same way it's treating the positive ones, so you get the same filling graph for a negative pitch as well as a positive pitch, but you get a better view of what's going on with the board. In any case, let's click the download button and try it on the real microbit board. And in a few seconds, we should see the very same sketch running on the real microbit board. And while it was kind of boring tilting the virtual microbit board in the browser, playing with the real microbit board is much more fun. Again, we can get the pitch and roll, but currently we are only displaying the pitch value. Now in the end, I want to show these values on the LCD screen on the big display, but I think that we can try one more thing, and that is to moving one single dot around this 5x5 LED matrix, and that way we can show both the pitch and roll value. So again, back into the MakeCode editor, I want to create a simple sketch that will move one single pixel around based on the tilting. Now I believe that the pitch and roll values go between -180 to +180, and I only have 5 positions going from 0 to 4, so I want to somehow remap those values. So I will go to Math and select the map block, and I want to remap the pitch, but I don't want this to go from -180 to +180, but maybe for example only from -80 to +80. And I want to remap it from 0 to 4. Now we want to also constrain this value so it will not go over those values. So I'll again open the math, and in here select the constrain, and I want to constrain the rotation to go between the same values, so -80 and 80. And you can see it's getting kind of big, and that's only one value because we want also the other value, and it will be the same thing, but this time it will be the roll value. So basically this will be the X position and this will be the Y position. Actually it will be the other way around. Now if you want to keep it simple and not use any variables, you can go to Basic and clear the screen first, so select Clear the Screen, and then go to LED and select Plot XY block, which will set the corresponding LED to be lit. And so for X, let's use the roll value, and for Y, I need to scroll all the way to the right side, I will use the pitch value. And as you can see, it's getting kind of big and maybe hard to maintain, but once the simulator restarts, our dot should be following the tilting, which is kind of cool effect. So one last time, let's also try it on the real microbit board. And maybe I should have restricted the angles even a little bit more, but you see as I tilted the board, the dot is moving around. And since we know how to get the pitch and roll values, we can move to the next step, and that is displaying those values on the LCD screen. Now the microbit is a nice board, but it doesn't have enough power to drive the LCD screen. It doesn't have enough performance and it doesn't have enough memory. For the reason we will be using what's called the intelligent display. This one is called Nextion, and what will happen is that the display will store all the images and it will do all the drawing. The microbit will just tell the display which images to draw and which numeric values to display. So let's put the microbit board aside for a minute and talk about the images first. For creating the graphics, I usually use the online tool called Photopea, which is similar to Photoshop, but it's free and online. And I would go to File New and create a new file in the size 800 by 480 pixels, which is the resolution of the display, and then draw stuff. But in order to speed things up, I've already prepared the file, which looks something like this. By the way, there is a link in the description of this video where you can download this file. You can see I have a few different groups, and every group shows this car in a slightly different position for both pitching and rolling. So I have 17 different states for pitch and 17 different states for roll. Now the file is using what's called the smart objects, and that's indicated by this small icon over the layer icon. And if I double click this background layer, for example, I have a few different backgrounds that I can choose from, and maybe I will go with this one. I will just save file, save as a smart object. And as I close the file, you will see that the main file has updated in a way that all those roll and pitch indicators has the updated background. By the way, if I hide the background, you can see that those pitch and roll images are non-transparent images, and that's intentional so we can use it for any Nextion display, because some of those cheaper displays don't support transparent images. Now you can play with this file for as long as you like, but what I will do now is to export those layers as individual images, and basically everything that has the -e- prefix will be exported as the image. So I'll export the background image, all the pitch layers, and all the roll layers. And I can do it by going into File, Export Layers, keep the default settings, and click the Export Layers button. And once exported and downloaded, this is the content of the zip file. So we have the background layer, then 17 layers for the pitching, and 17 layers for rolling. So it's time to start the application for the Nextion display, which is called the Nextion editor. In here I will create a new file, and I need to select the display that I have. Now, since I'm using the 800 by 480 pixel resolution, I have quite a lot of displays to choose from. For the basic one, I can use a 5-inch or the 7-inch. For the enhanced, I can also use a 5-inch or 7-inch. And I believe that's also true for the intelligent one. So again, here I can use a 5-inch or 7-inch. So all those 6 displays have the same resolution. So it's really up to you which one you purchase and which one you use. Now in this particular case, it doesn't matter that much which series you choose because we are not using any special features. So you can also go with the basic one. And that's actually the one that I will be using. So I will select basic and the 5-inch model, then go to display and select the orientation, which will be 0 degrees, and click the OK button to create a new project. Now as a first step, I want to add all my exported images, so in the Pictures tab I will click this plus icon and select all the exported images. So now we have the background, all the images for pitching, and all the images for rolling. So I'll click on this empty page, and for the background, which is this STA property, I will change it to image, and for the picture I will select picture number 0, which is our background. And then I will add one more picture, that will be for pitch. So for the picture I will select, for example, the first pitch image, and one more picture, and that will be for roll. So for that one, I will select, for example, the first picture for rolling, which is picture number 18. Now I think that you can eyeball the correct position, but you can also jump to Photopea and get some exact numbers. And that is by clicking this distances checkbox. Unfortunately, it's showing the distances for all the layers inside. So what I can also do is I can temporarily merge this layer by clicking Ctrl-E or selecting layer, merge layers. And now it will show us proper distances. So it's 440 from the left side and 90 from the top side. So for this one, the X is 440 and 90. And you can see that we were very close to those numbers. For the pitch image, let's also merge it, so layer, merge layers. And now the X is 60 and Y is also 90. So for this one, X is 60 and Y is also 90. Now you might be surprised that we actually don't need anything more than this. We have the background layer, we have the left image for pitch and right image for roll. And as I said previously, the task for the microbit board will be to tell the Nextion display which image to show. So for the pitch image, we are currently showing picture number 1, but we can also show picture number 2, or maybe 5, or maybe even 10, we can actually go all the way up to 17. So again, the task for the microbit will be to tell the Nextion display which image to show based on the pitch value and the roll value. And we can actually simulate this inside the Nextion editor by going into the debug mode. And here we can type in custom instructions, the ones that will be later on sent by microbit board. Now you can see on the right side that the name of the picture component is called P0, so I'll type in P0 dot, and the image name is called PIC, so PIC. And I'll say equals, for example, 1. And as I press the enter key, I will see the first image. I can also say p0.pic equals 17, and that will show me the last image. And I believe if I go with 9, there will be no pitch. I can do the same thing also with the other image, only this time the name of the component is called P1, and the images for roll go from ID 18 up to ID 34. So if I jump to debug, I can type in p1.pic equals 18, that will be the first image, no change, all the way to 34, that will be the last image. So now we see that everything works. Let's upload this to the actual display, and we can do this in 2 different ways. We need to generate the TFT file by going to File, TFT file output. And here, if you click the output button, it will generate the TFT file and open the file location. What you want to do is to use the microSD card and copy this file onto this microSD card. Then put the microSD card into the Nextion display and power it off and power it on. And if everything goes well, you will see that the TFT file is being copied from the microSD card into the Nextion display. And once this is done, you want to unplug it from the power and plug it again. And you should see our screen design with the pitch and roll indicators. Now there is no touch and there is no logic, so it's just a static screen. Nothing is really moving, but that's the task for the microbit board. Now we haven't talked about the form of communication between the microbit and the Nextion display. The Nextion display requires all those commands to be set using the serial communication, which is thankfully something that microbit supports. And I've already showed you how those commands look like, but I did forget to tell you one important detail. So if I open debug again in the Nextion editor, I can again type in p0.pic equals some value, for example 10, and it will change the image. But other than sending those individual characters, we are actually sending 3 more which are not visible by default. But if I switch to the hex view, you can see that those were the individual characters being sent. So those individual characters are p0.pic equals 10, so 10. And then we have 3 ff characters. And those are actually needed to tell Nextion display that anything that was sent before is comment that should be executed. So we are ending with ff character, which is decimal value of 255, and we need to send it 3 times every time we send a new comment. So with knowing that, we can jump back to the microbit code. This is what we have from the last time, and we are lighting a single LED based on the pitch and roll values. So as I tilt the board, the single LED will move around. Now what I want to do is, instead of lighting up the LED, I want to send those values using the serial port. And that could be accessed by going into the advanced, and there is this whole serial section and also serial more section. And what I want to do is I want to write a new line, so I'll select serial write line and put it inside a forever loop. And because my data will consist of multiple elements, I will open the text section and select the join block, which I will drag inside the serial write line function. Now as a first thing, we want to print p0.pic equals, and the second part should be the value, and I think that we can reuse the values for plotting the LED. Now our images only go from -40 to +40 degrees. So let's also restrict the values in the same way, so I will map the pitch between -40 and +40 in both places, and the images should go between values 1 up to 17. Now after we send the p0.pic equals some value, we need to send those 3 special characters, so I'll click this plus icon, actually 2 more times, like so. And you can see that now it jumps to the next line, and I want to print the character ff, which is the decimal number of 255. So inside the text section, I will select the text from character code, and the character code should be of course 255, and then I will copy it and paste it 2 more times, so 3 characters being sent. Let's slow things down a little bit by adding some small pause, I don't know, 50 milliseconds, and we can restart the simulation. And once the simulation is running, we can select the show data from the simulator, and you can see that it's showing us that p0.pic equals 9, which is the middle position, and then those special characters. Now as I tilted the board, you will see that those numbers are changing, but if I pause the simulation, you will see that we are getting the decimal values, for example 9.4, but we need to have integers all the time. So I will go back into our simulation, and inside the math section, I will select the round block and just put it inside here, and that should fix the issue. So let's restart the simulation and show the data again, and now we should only see the integer values going from 1 all the way up to 17. So it seems to be working just fine for pitching. Let's do the same thing for a roll. For that, let's duplicate this block by right-clicking and selecting duplicate, and we need to change few things. So first of all, the image name, the object name is p1. We want to get the roll instead of pitch, and the images are numbered from 18 up to 34. But I think that other than that, that's pretty much all that we need to do. So if I restart the simulation and show the data from the simulator, now I see the values for the pitch going from 1 up to 17, and for the roll going from 18 up to 34. So I think that at this point we are almost ready. Now currently the serial communication is going through the USB cable into the computer, but we want to use some of those pins on the microbit board. And for that we can open the serial section, and we can select this serial redirect to block. So I'll put this into the on start, and I want to use some pins for TX and RX lines. And I think that I can go with the default one, which is a P0 and P1. Those are the big pins on the microbit board, but I need to also set the speed. And since the default speed of communication for the Nextion board is set to 906,000 bauds, I think it makes sense to set it here as well. I mean, you can change it for the Nextion board, but it's just easiest to keep it to default. And I think that we can call this sketch the final one, so there will be one more download to the microbit board, and all that's left to do is to connect the microbit with the Nextion display. Unfortunately, the microbit pins are not super simple to connect to. You can use crocodile wires, but I really hate using those. Thankfully, you can get a lot of expansion boards, for example something like this. And if you slide the microbit into this slot, you now have access to all those individual pins, and you can use standard jumper wires. So this is the default cable from the Nextion display. The red is 5 volts and the black is ground. This is already connected to the USB power supply. The yellow wire is labeled as RX on the Nextion board, and that should be connected to the TX pin on the microbit board. And just a quick reminder, the TX line is a pin number P0. So I will connect the yellow one to pin number P0. And then the blue label, which is labeled as TX on the Nextion board, should go to the RX pin on the microbit board, and the RX on the microbit board is the pin P1. So here the blue cable will go to pin P1. Now in order for this to work, we need to also connect the common ground. So I will take one more jumper wire and connect the ground from the microbit board to the ground of the Nextion display. And I will connect it to this USB power supply board because I have one empty pin in here. And once everything is connected and I provide power for both the Nextion display and the microbit board, I should see the project running, and as I tilt the microbit board, those images should be changing. One very important detail, I had to remove this pause, this delay from the forever section, otherwise it wasn't working, not quite sure why, but when the pause is not here, it works just fine. You can make the project better by adding labels which will show the exact values, but let's leave something for the next time. Here is the same project running on the Intelligent series. The display is a little bit brighter and the animations are smoother. As usual, all the source files for this project are on GitHub, the link is in the description. From there you can download the Photopea file and adjust the graphics to your needs, for example by changing the background or just swapping the image with your own one. If you have any questions, please put those down in the comment section. If you want to learn more about the Nextion displays, I have a playlist with few of the videos. The link should be visible on the screen right now. And that's pretty much it for today. Thank you very much for watching and I hope to see you soon. Thanks and bye.